So just like we talked about with carbon sequestration methods, we can use what we know about aerosols and clouds to manage the incoming solar radiation. We call this geoengineering or climate engineering. It's defined as a broad set of methods and technologies that aim to deliberately alter the climate system in order to alleviate impacts of climate change. So geoengineering would be things like carbon sequestration, reforestation, artificial upwelling, all of that we already talked about. But specifically for aerosols, we can do solar radiation management. And this proposes to counter the warming associated with increasing greenhouse gas concentrations by reducing the amount of sunlight absorbed at the surface, right? So we can think about if we increase the number of clouds and whiten them, right? Send out aerosols that'll cause clouds to be whiter, we could increase that albedo. We could change the roofs of our buildings. So rather than having this, really dark black roofing tiles, we could change it to white roofs, which would cause the roofs to be more reflective, higher albedo. We could plant crops that tend to have leaves that reflect the sunlight more than absorb them, right? So we can use a lot of what we know about sulfates and clouds and albedo for solar radiation management. Now, just like the other methods of geoengineering we've talked about, there's a reason we're not working with these at scale at present, right? And that's because they don't just change the amount of incoming solar radiation, they also have other impacts on our ecosystem. For example, solar radiation management that deals with clouds will not only increase albedo, but it could also change the amount of rain, the amount of precipitation that we get. So these two images are showing, the top one is showing how temperature could change with solar radiation management and without solar radiation management. And you can see that with solar radiation management, we can keep the temperature fairly low. However, there's a side effect, and if you go down to that bottom plot, you can see that by keeping the temperature lower through these solar radiation management activities, we would also inadvertently be decreasing precipitation, right? Which we obviously don't want to do. We don't want to cause any more droughts, right? We don't want to disrupt agricultural processes even more. You can also see in both of these plots that as soon as we stop using solar radiation management, then the temperature spikes right back up to what it would have been without these management practices. This means that, if we're reducing precipitation all the way up to the point where the earth just can't handle it anymore and we have to stop these practices because of that, well, then it's like we had never done them in the beginning, right? Because the temperature goes right back to what it would have been, which is unfortunate, right? So we have to think about ways, how can we incorporate solar radiation management without also having these negative impacts on precipitation, which, right, is something we're still working on, still studying.